Hello, this is Mr. Best. Welcome to homework questions 42 through 46. Estimate the size of each angle below to the nearest 10 degree. A right angle is shown for reference, so you should not need a protractor. So as we're looking at each of these, we're just kind of estimating them, remembering that a right angle is 90 degrees. So somewhere there, so this one's a little bit bigger than 90 degrees, and if we're going by increments of 10, we can probably say that it's 100 degrees. Once again, remembering that a right angle is 90, and then we almost have another right angle here, a little bit short of it, so two 90s would be 180, a little less than that, so probably 170 degrees. Don't forget to put the degree symbol. On C, maybe a little bit tougher to tell, but if you have your right angle there, it kind of looks like it's in the middle, maybe a little bit more. So half of 90 would be 45, so maybe a little bit more than that. We'll go with 50 degrees on that one. Question 43. Rosalinda examined the angles at right and wrote the equation below. 2x plus 1 plus x minus 10 is equal to 90 degrees. Does her equation make sense? If so, explain why her equation must be true. If it is not correct, explain what is incorrect and write the equation. So we know that the angle to the right over here is a right angle. You see the indication by the box in the corner there, so that means it is 90 degrees. So since we know it is a right angle, we also know that it is 90 degrees. So therefore, if we take this angle, which is x minus 10, and we add this angle, which is 2x plus 1, we should be able to add those two together to create the 90 degrees. And that's exactly what Rosalinda did. Took 2x plus 1 plus the x minus 10 is equal to 90 degrees. So does her equation make sense? Yes, it does. It is correct because the two angles make up a 90 degree angle. Part B, if you have not already done so, solve her equation, clearly showing all your steps. What are the measure of the two angles? So we're going to take the 2x plus 1 plus the x minus 10, combine the like terms. That'll be 3x, and then plus 1 minus 10 would be minus 10 or minus 9 is equal to 90. Add 9 to both sides. We get 3x is equal to 99, and that does represent degrees. Divide by 3, and x is equal to 33 degrees. And so I'll put my degree symbols on there. And so we know x is 33, but that's not what the question is. It wants to know what the measure of the two angles are. So the two angles are x minus 10, or in this case, 33 degrees minus 10 degrees, which would be 23 degrees. And then the other one we could figure out by taking 90 minus 23, but let's plug it in and see what we get. We got 2x plus 1, so 2 times 33 degrees plus 1 degree. That would be 66 degrees plus 1 degree is equal to 67 degrees. So is it true that 67 degrees plus 33 degrees is equal to 90 degrees? Whoops, not 33. I was looking at the wrong number. Here's the other angle, 23 degrees. I was looking at x, but that will add up to 90 degrees, so that does work. So what are the measures of the other two angles? One of them will be 23 degrees, and the other one will be 67 degrees. And they add up to 90, so that works out. And then verify that your answer is correct, which we kind of already did, because we took the 23 degrees and added the 67, and it should give us a right angle of 90 degrees, and it does. Question 44. Angela had a rectangular piece of paper and then cut a rectangle out of a corner as shown below. Find the area and perimeter of the resulting shape. So there's lots of ways that we can look at this. Let's just go ahead and start with the perimeter. The perimeter is the distance around, so if we want, we can just add up all the sides. We can take, I'm going to start with the 16, then add 21. So I'm just going to go around here. Then add 9, then 15, then we add our 7, and then to finish it off, we add 6. So if we add all of that up, we will get a perimeter of 74, and this is being measured in centimeters. Now to find the area, once again, there's a couple different ways we could look at this. We could break this up into two parts. We could find the area of this rectangle and then add the area of this rectangle. Let's do that first so you can see that. That would be 6 times 16 to get the area of the first one, plus, make sure you get the correct side here, that would be 9 times 15. So this side length is 15, this is 9, and so let's see what we get when we add all that up. So that'll give us an area of 231 centimeters squared. The other way that we could possibly look at this is actually finding the area of the entire rectangle as if the piece of paper had not been cut yet. And that would be 16 times the total length, which would be 21. But then what we'd have to do is subtract off the piece that was cut. So that's 7 by 15. So we'd actually subtract the piece that was cut off. So this is just another way to look at it. So we get 336 minus 15 times 7, which would be 105. So if you take 336 minus 105, you will get an area of 231 again. Should get the same thing we do, centimeters squared. So different variations on how to find the area there. Once again, we're not looking for one specific way. We all think different ways. So as long as you get the area of 235 centimeters squared of what's left, then you did a good job. Question 45. For each equation below, solve for the given variable. If necessary, refer to the math notes in lesson 114 for guidance. Show the steps leading to your solution and check your answer. So once again, we're working on solving one variable equation. So on part A, we have 75 is equal to 14y plus 5. So we only have one variable term, so we'll move the constant. We have 70 is equal to 14y. And if you divide by 14, y is equal to 5. And don't forget, you do need to check your solution again. B, we have negative 7r plus 13 is equal to negative 71. So similar to A, we only have one variable term, so I'm going to work with the constant here by subtracting 13, so that would be negative 84. And then we can divide both sides by negative 7. So therefore r is equal to 12. Part C. Now this one we have a variable term and a constant term on both sides, so we're going to have to move both of them one way or another. So I'm going to go ahead and work with the variable term and subtract 7a to both sides. We get negative 4a plus 11 is equal to negative 13. So now I need to work with the constant, so I'm going to subtract 11 to both sides to get negative 24. And then now we have a variable term equal to a constant, so we can divide by negative 4 in this case and get a is equal to 6. And then the last one, D. D, we have 2m plus m minus a equals 7. Now we do have two variable terms, but they're on the same side, so we can just add those up. 2m plus 1m is 3m. And then the constant we can add to both sides would be plus 8. 3m is equal to 15. Divide both sides by 3. M is 5. Question 46. On graph paper, draw 4 different rectangles that each have an area of 24 square units. Then find the perimeter of each one. So I have two different graphs here, so I'm going to do 2 on each of them. So 24 is what the area needs to be. And so what ways can we get 24? Well, we could do 1 times 24, 2 times 12, 3 times 8, 4 times 6. And you might think that's it, but there's not. Those are the whole numbers we could use. We could also go the other way. 6 times 4, it's just going to change the orientation. But we can also, use other numbers. They just won't go in evenly. So let's see. We need to do 4 different ones. So we'll do the 1 by 24. So I went ahead and just put them all on the one graph so we can compare the 4 of them together. And I got a 1 by 24, a 2 by 12, a 3 by 8, and a 4 by 6. And the perimeter, I just took the length and the width and added them up and multiplied it by 2. I just doubled it. And so I got 20 units for the 4 by 6, 22 units for the 3 by 8, 28 units by the 2 by 12, and 50 units the 1 by 24 in terms of the perimeter. So we've drawn 4 different rectangles, and they all have the same area, but you will see that they have different perimeters.